So 3, 2, 1, we are going to be adding and subtracting integers. So we're going to start off with some vocab. So the opposite of a number is the same number, but with the opposite sign. So we're going to be looking at positive and negative numbers. A number and its opposite are both the same distance from 0 on the number line. For example, the opposite of 4, or positive 4, is negative 4. And the opposite of negative 9 is 9. Now, when you see a number like this without any sign in front of it, we always assume it's positive. Okay, a negative sign will always have a negative in front of it. Generally, we don't write the plus sign in front of a positive, we just leave it alone. Okay? Elliot is so interested in the frogs that he is developing a video game about them. In his game, a frog starts on a number line like the one below. The frog can hop to the left and to the right. For each part below, the game starts with the frog sitting on the number 3. So if we're looking at this number line, okay, first let's talk about what does it mean to move left and right on a number line. So let's first look at if we're moving to the right. So if we're moving right, are we moving in a direction where my numbers are getting bigger or smaller? They're getting bigger, right? As I go further this direction, they get bigger. I'm also moving in the positive direction. Now, opposite of that, okay, I'd be moving to the left. And if you notice, as I move to the left, my numbers get smaller. So this, I'd be moving in the negative direction. So if the frog starts at 3, hops 4 to the right, to the left 7, and then to the right 6 units, where will the frog end up? So go ahead and pause the video and work that out and see where you get the frog to land. All right, so we start at 3. We move to the right 4. 1, 2, 3, 4. We're at 7. We move to the left 7. 1, 2, 3, 4, 5, 6, 7. And then we move to the right 6. 1, 2, 3, 4, 5, 6. So we ended at the number 6. If the frog makes 3 hops to the right and lands on 10, list the lengths of 2 possible combinations of hops that will get him from 3 to 10. So if you remember, our frog is starting at 3. So our expression has to start with a 3 because that's where he started. And that doesn't count as a hop. That counts as where he is starting at. So our frog is starting at 3. And we need him to get to 10. And we need him to do that in 3 jumps. So one option we could do is we could have him jump 2, 2, and then 3. So 3 plus 2 plus 2 plus 3. That'll give us 10. So go ahead, pause the video and see if you can come up with another solution. Okay. Another one you could have done is 3 plus 5 plus 1 plus 1. You could have done 3 plus 4 plus 2 plus 1. Or you could have done 3 plus 3 plus 3 plus 1. Any of those combinations would have worked. If you have them in a different order, that's fine. No big deal on that. They're all the same. If you want to try that additional challenge, you sure can, but we're going to go ahead and skip to the second page. We're really going to focus on opposites now. So how would the frog hop to meet the following requirements? So if our frog is at 3, he makes 1 hop and lands on 6. So we got to think about what direction is our frog going to hop and how many to get to 6. So if we look at ours, he's at 3 and he hops 1 hop to get to 6. How much did he move and in what direction? And hopefully you see that he moved to the right 3. The next one says from 6, he makes 1 hop and lands on the opposite of 6. So if we're back at our number line, he makes 1 hop and lands at -6. So remember, the opposite of 6 is -6. So How far did he jump and in what direction? Hopefully you saw we moved to the left 12. Okay, and a lot of people said that if 6, he moved to the left 6. Well, look what that gives us. That gives us 0. So we have to go all the way to -6. We have to go 6 more. So that's where the 12 comes from. From the opposite of 6, make 1 hop to land on the opposite of 6. Whew, that's a lot of words, isn't it? So the opposite of 6, let's look at this piece right here. We said that's -6. The opposite of that would just be 6. So how far and in what direction? He'd have to go 12 to the right. So we're just going back to where he started. So you're going to see different math problems with the opposite of 6, and we use math symbols to represent that. So how we would write that out is the opposite of 6, so we'd write the opposite of 6, which just means 6. So when you see that double negative, that really just means a positive. You're saying the opposite of -6, okay? So for a while, you guys have learned that the subtraction symbol just means to subtract. Okay, well, it also means opposite and it also means negative, and that all is the same thing. All right. While designing his video game, Elliot decided to replace some of his long sentences describing hops with symbols. For example, to represent where the frog traveled and landed in part A of problem 390, he wrote 3 plus 4 minus 7 plus 6. This is the first problem that we did on the front side, 3-90. So instead of the words, we just have the expression. And in a lot of math, they'll just give you this. You're not going to get a little expression describing where a frog jumps, okay? You're just going to get the numbers. But in your head, you can think about, okay, I start at 3, I head to the right 4, so I'm at 7, I go to the left 7, so I'm at 0, and then I go to the right 6, so I'm at 6. So in my head, I still do the same thing. I'm still moving on the number line. I don't have a little sentence describing that to me. So in A, it says, how does Elliot's expression represent words in part A of problem 390? So basically what we're trying to figure out is, what do the positive numbers tell me? And what do the negative numbers tell me? So the positive numbers tell me I'm moving right. And the negative numbers tell me I'm moving left on my number line. Question asks, where did the 3 come from? So if I look at that 3, it's my very first number. So since it's my first number, my 3, that's my starting point. That's where I first go to on my number line. So go ahead and try B. It says, if another set of hops was represented by 5, minus 10, plus 2, plus 1, describe the frog's movements. Where did the frog start and where did he end up? So I'm actually going to type this because this will be a lot easier and neater. So it says, describe the movement. So we're going to be using words. So we start at 5 on our number line. And then it says -10. So we hop to the left 10. Then we have a +2, so we hop to the right 2. And then +1. We hop to the right 1 more. And it says, where does the frog start and where do we end? So we started at 5 and we ended at -2. So hopefully you have that written down when you did your solving. All right, we're almost there. For C, it says one game used the expression -5 plus 10. Where does the frog start? Where does it end? And what's special about the ending point? So go ahead and see if you can solve this one. Okay, so where do we start? And where do we end? So our first number is always our starting, so our -5. And then if we move to the right 10, where do we end? We land on +5. So when I'm looking at these two numbers, I have a -5 and a +5. And hopefully you can see, well, those are opposites. That's what makes them so special. Last question. Another game had a frog start at the opposite of -3, hop 5 units to the left, 9 units to the right, and then hop to its opposite position. So we're going to write an expression, and when it says write an expression, we just want the numbers, but remember, no equal sign. So it says we start at the opposite of -3. So the opposite of -3 is 3. We go 5 to the left, so left is -5. And then 9 units to the right, so the right is 9. So if I look at where I'm at so far, I'm at the number 7, but it says we hop to the opposite position. So the opposite of that is -7, and this is my ending. All right, and that is 3, 2, 1.